Okay, guys, the theorem that we are given here, it's a chord theorem in short, but in full it states that the angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternate segment. Hence, we call it a chord. So they're saying this angle, you see this angle CBD, this one here, this one is equal to, sorry for that, this one is equal to this one. So this is called a chord. So this angle is equal to this one. So how do we go about proving that this angle is equals to the other one? So what we are required to prove? We are required to prove that CBD is equals to BED. CBD is equals to BED. This angle is equals to that angle. So now what you have to do, you have to, let me draw a diameter, say O and F. Okay, you draw a diameter. You know a diameter, it's a line from the other part of the circumference of the circle passing through the center of the circle to the other part of the circumference of the circle. So we can start it from this part, goes down to B. And then this is our diameter. Let's call this one what? F. So this is our diameter. So let's make it like this. Let's make the line look like this so that you can see that this line we just edited it for or on our own. And now you've drawn that diameter, and let's join EF now. Join EF. We're joining EF, and also let's make it a dotted line so that you can okay. Now we see that there are now divisions of the angles. So let's name this angle 1, angle B1, and this one here angle B2. I hope everyone can see that. This is angle B1, B2, and let's name this E1 and E2 here. And then now we can see that angle B1 plus angle B2 is equals to 90 degrees. What's the reason? You see, we say this is a diameter. A diameter passes from the center of a circle. So a line drawn from the center of a circle to the circumference, it's a what? It's a radius. And we have that line going to meet what? A tangent. So from the theorem, tangent, that tan perpendicular to radius, we can clearly see that this whole angle now is what? This angle is what? It's a 90-degree angle. So this one is 90 degrees. Your reason it's 10 perpendicular to radius. And then now we can see that E1 plus E2, it's also equals to E1 plus E2 also equals to 90 degrees. What's the reason? We know that an angle subtended by a diameter is equals to 90 degrees, or an angle in a semicircle is equal to 90 degrees. So we can see BF is a diameter. It subtends an angle. This BF subtends an angle here, of which is the whole of E1 and E2, and that gives you 90 degrees. Your reason is going to be angle in a semicircle. And then now we can see that angle B1 and angle E2, they are equal. B1 and E2 are equal. What's the reason? But angle B1 equals to E2. What's the reason? These FD subtends what? Subtends equal angles at the arc. FD subtends equal angle at the circumference. So FD subtends E1 first, and FD again subtends B1 at the circumference. Hence E2 and B1, they are equal. FD subtends equal angles. So if this one is equals to this one, automatically this one has to be equal to this one, because both of them, when you add, we get 90. Let's say from here now, we say we take B1 to the other side. B2 to the other side. That means B1 is going to be equals to 90 minus B2. And then we take E1 to this other side. We'll have 90 minus E1. That means B1 and E2, they will both be equal, since they are both equals to 90 minus B1. If you can just do that maths, you will see it's going to be clear to you. But you don't have to show those steps. You can just write this as it is and say, therefore, angle B2 is equals to angle E1. So from here, it has to be easy for the person to understand why you're saying B2 is equals to E1. And you can therefore conclude that you can see that CBD is B2, is basically B2. CBD is this angle B2, and also BED is basically this angle. BED is this angle. So you can now conclude, say therefore CBD is equals to angle BED.